back to database management. In this module, we will discuss subselect statements and table views. Here's what you will learn in this module. You will write and use nested select statements, also known as subselects, and you will learn how to make your queries reusable by turning them into table views. Let's first talk about how to retrieve data not just from one table, but from two tables, and then relate the outputs that we are getting to one another. Let's say we have a customer named Steven. Steven normally has a membership card, but he lost it, and he cannot for the life of him remember what his customer account number was. So we take a look at our database. We know that we have all the information about our customers in our person table. And in our person table, all we can find is a person ID, but no customer account number. So we keep looking through our database and we find our customer account person table. In this customer account person table, we see we have a person ID. That looks promising. And even better, we have a customer account ID. So how can we build a query that combines the customer account ID with Steven Bernstein's name? We can find Steven Bernstein's person ID relatively easily with a combined where clause. And we see in the person table that his person ID is 12. Now we can use this person ID, which we now know, namely 12, to look up the corresponding customer account ID in our customer account person table. That happens to be 7. But for that we need two queries. Can we actually make it so that we need just one query? You bet we can. We can say we're going to select the customer account ID from customer account person, which is exactly what we're doing here, where the person ID can be found in, and then we open and close a paren, the output of select person ID from person, where person given name equals Steven and person family name equals Bernstein. Yes, you saw that correctly. Within this query, we have two select statements. One select statement is in parentheses, and that is in fact the first select statement that we have right here. That is also called the inner query. The inner query gives us a result set that we can use to run the outer query. Both queries are connected with the keyword in. That is the structure of a nested select statement or a subselect. A subselect is a select statement that sits inside a parent select, insert, update, or delete statement. The inner query, which is the query that we're seeing in the parens here, runs first to build a result set. That's what we did manually in our first attempt. Then the outer query runs in order to pick from the inner query result set the information that is interesting and required. Here, that is the customer account ID that is being returned right here. Both queries are connected with the keyword in. Awesome! What if we wanted to find all the customers who have paid more than $15 to us? here we would be using a correlated subselect. A correlated subselect is just like a subselect with an inner query in parentheses and an outer query. And the inner query does provide the subset that the outer query is evaluating. The one big difference is that correlated subselects are connected not through in, but through a comparison or through arithmetic. So what we are seeing here is our select distinct customer account ID from customer transaction, where, and here is the kicker, 15 is less than. So we want to find all the transactions that are more than, right? And then 15 is less than, and rather than giving it another absolute value, we use the output of the subselect query, this nested query here, in order to compare each row that this query produces with the 15 here, and only if the result from our subselect query fulfills the criterion that it is in fact greater than 15, will it be added to the result set. The result set is what we're seeing right here. Subselects can come in all sorts of useful. Here we are selecting the movie ID and we're counting all the rows in our movie rental table. But we are also selecting, and that's what you're seeing here, the count, and we're dividing it by the count from movie rental times 100. That's the percentage. But even better than that, we are grouping our results by movie ID. That way, we can find the percentage of our movie rentals per movie. Let's say I want to find out how many percent the revenue that we're getting from the rental of each movie is of our total revenue. So I am going to use movie ID and then the sum of the rental fee, that's what we're seeing here. And then I'm going to do my math, namely with the sum of the rental fee divided by the sum of the rental fee that we have in movie rental times 100 as percent. And we're going to group that now. And here's the trick with the group by. We're going to group that now by the movie ID. That way, I see the percentage that the sum of my rental fee is per movie of the total rental fee. We have seen how intense the queries can get that we write. So, do we really want to retype such long queries every single time we need the result? The answer to that is probably no. That's why we have views. Simply put, a database view is nothing else than a stored SQL select query. This SQL select query typically combines columns from one or more tables into something that looks like a table. That is our view. We can treat this view just like a regular table and query it with other SQL select statements. Views are often used with subqueries or with table joins, that is, to combine information from various different tables. and they can help us really re-architect our database the way we need it to in order to make our life easier for reporting purposes and for business intelligence purposes. As you can see here, views have many advantages, not the least of which is that we use views to build the external layer for our database. That is, we surface only the data to our users that we want our users to see. So that can be very helpful. On the other hand, we also know that whenever we access a view, we don't access a table, but we actually run the SQL statement, that select statement that builds the view. The advantage of that is that we always get the latest data because that select statement grabs the latest data from the underlying tables. The disadvantage of that, however, is that if the underlying tables change, then our view can break. Here is how to create a view. We use the same create command that we use for tables. Here you're seeing it with create or replace view, just in case we are going to replace the view that we already have with our new select statement. So create or replace view, and then the name of the view, namely sales employees, and here's the connection to our select statement, and that is as. So we have create or replace view, sales employees, as. And now comes our select statement. Select employee ID, last name, first name, and department name from. And here we are combining that information from two tables. The first table is employees, and the second table is departments. And now we are matching that information up, where the department ID that we find in the employees table, that's the first one here, is the same as the department ID that we find in the departments table. That's the second table here. And since we are only looking for the sales employees, we are going to filter on the department name column in the departments table. And we're looking for the values that have the string sales somewhere in them, that contain the string sales somewhere. So this gives us then a list of all sales employees, and it combines information that we find in the employees table and in the departments table. And here you're seeing a very common way of combining and matching up data from two tables, namely with the where statement here that matches a foreign key with a primary key, and then filters another time on a value in a column. This is also explained on page 147 in your book. Let's review what we have learned in this module. We have learned how to write and use nested select statements, also called subselect statements, that consist of an inner query that runs first to give us a subset or a result set from which an outer query selects only the items that we're looking for. We have also, because our queries become more and more complex, found a way to save these queries in the form of a table view. Thank you so much for watching, and I look forward to seeing you in a future module.